So the first thing that we're going to do is open Colab. I'm assuming, please let us know if there is no Python, if there is someone with no Python knowledge. I'm assuming at least a little bit of Python knowledge. So we're going to use Colab as a way to run a Python environment to run the experiments. It has the advantage to have some GPUs for free to handle most of the Python environment for us. So it's pretty useful. Like, we don't have to install anything to run this demo, and you can run it with us. So the first thing that we need to do is open Google Colab link there is on the repo. And you need to copy this notebook that we have here and paste it here in Colab. Like, basically, we have recent, Google Drive, GitHub. Then we can put the link, click on the search. And it's going to automatically get the notebook in here. The second thing that we want to do is select a GPU runtime. That is pretty important. Okay. May not have. Yeah. Here you can go to change runtime type, GPU, like the default is none, but you can select GPU and you can select site. Basically, you can run it. If anyone has any doubt up to this point, let me know. I think I may need to change my account because I don't have a lot of Colab. Yeah, you should make sure that here it says runtime type GPU. So if anyone has any problem up to here, let us know. The main idea of this track, as I told, is to let know people a little bit of the data that we have in OpenStates, how we can access it, and what can we do with it. So in the legislative process, there is a lot of data being created. Like, not necessarily all of it is structured, but we have what are the build text that is pretty unstructured text data, but we have also middle metadata. We have when it was introduced, who was the person that created or introduced the bill. We have people data, where is congressman, state, age, the chamber that they belong to, vote data, committee data, sessions. So there is a lot of data to explore. There are a few ways that we can access some of that data in OpenStates. So one of the main ways is obviously OpenStates page. Sorry. So we can go to OpenStates.org and we can search there. So if we are a regular user that needs to find a bill, that may be enough. But if we need to do deeper analysis or we need to analyze more data, there are other ways. The main recommended way when we have to analyze a lot of data will be the bulk exports. So in this page, if specifically we have some information about what data do we have. So we do have legislative data in CSV and in YML. We have bill data, we have vote data in JSON, in CSV, and we have some geographical data. That one may be harder to do. And we can also access a database dump. So if we need all of the data, we don't have to start from scratch. We can just copy the data dump and we can work on our own. So for example, if we go here to the links, we can select for each state, it's going to be some information about the session. We are going to work specifically with Minnesota in this case. So here is the information for Minnesota 2021 regular session. That is one way to connect to the data. it's free access. You don't need to have any API or any type of access to get it. And it's mainly bill and people data, but also other things that we have seen. The other main way to access the data is through the API when we need to do it programmatically, but maybe with a significant amount of less data. So here is the documentation you want to explore it. Here are a few of the methods that you can try, like we can get the jurisdictions, we can get the people, we can get bills matching certain criteria, for example, for search. And here is a basic documentation that is in the notebook. Here is some more detailed documentation, like we have the Open States API Swagger. So if we want to see how does a jurisdiction call looks like, what are the parameters that we can use, default values, then we can take a look here. How do you get, so the first thing that you need to do is create an Open States account to use the API. Once you create it, you can select your name in here in Santiago. In this case, it's my username. And if you select it, it's going to automatically show you the API key. So I'm not going to click it. But once you create your account, you can click in your username and it's going to get you to that page. And the latest one that I wanted to show you was PyOpenStates. This is a Python library for accessing this data. It doesn't have all of the options that the API has, but it's also easy to use if you're working in Python and you don't need to get a lot of the API related code. It has get legislator data, for example, get bill, search bill, set API key if you want to use it. It's also pretty useful. Okay, so now let's do something ourselves. We are going to get some data from Minnesota for analysis later. So basically, to run a cell, you just have to press Shift Enter. So let us know if you have any issues. It's relatively straightforward. The first thing that, or you can just click right click left here in the play button. But we're going to import some required things that we need. This is going to tell you that this is not a Google code, but it's safe, so we can run it anyway. Yeah. And then to download the data, we are using request to get the data that we get from OpenStates. That specific Minnesota file that I showed you, it's a zip file, and we're going to extract all of that information in that zip file. Takes a little bit of time. And then we are going to show a little bit of the files that we have. Like, I'm going to add here a little bit more so we can see which files did it create. So basically, when we download that dump of data from Minnesota session, we get what are the bill actions, what are the related bills, some bills data, bill sources, and sponsorships, bill versions, and organizations. And if we want to get like a preview of how the data is it's a CSV, so we can do a head of the data and we can see that there is some ID, an identifier, classification, session identifier, jurisdiction, and classification. So that is some of the data that we have in here. If there is some question in the chat, please let me know, or you can manage it. Thanks. Okay, so that is a quick review of how we can download the data. We could change this link for other one of the links in here. We want to work with Mississippi, with Minnesota, and it's going to still work. We only need to change the name of the bills and the name of the documents. So why now we have this data? What do we do with it, or why it's useful? Like, there is a lot of people and business trying to affect public policy, as we all know, and public policy affect us people and beings every day in a lot of different ways at federal level, state level, city level. So there is a big impact. Like if we don't do anything, like there is still the default environment and the default option that we are right now. We're going to continue that way. So the good thing of open states and open data is that it gives tools to individuals and smaller groups to also affect change and get their goals and move legislation in their favor. So first, some primer, like some interesting questions that we could ask about this information is, who is this going to support this bill that is introduced right now? How likely is this bill to pass? Like, what is the legislation regarding this topic? I don't know, telecommunication, healthcare, voting rights that I care about in my state, or what is the relevant parts of information in this bill? Those are things that could be important for us and could help us understand legislation better. Not all analyses are possible. Like we have to take into account that there is a lot of unstructured data. There are not necessarily a lot of data for some events, like sessions occur once a year, twice a year. Like there is not 1,000 or 1,000,000 sessions of a year. So we are not going to have a lot of data points for sessions and another things, but I think that should not discourage us of analyzing the data that we have and basically creating some sound and good insights and analysis with the data that we could analyze. There is a lot of different types of data created and different types of analysis that we could run. We could run just a simple exploration and visualization. We could do some statistical testing on voting data. We could try to predict votes. We could classify bills. Like there is a lot of different things that we could do. For the hackathon ideas later, it could be interesting. And we're going to talk that a little bit later. But in this specific demo, we're going to focus a bit on unstructured data and text, because some of the most important parts of the data is in there, like bill data, that is text data, unstructured data, and also regulations, for example. So we are going to talk a little bit about NLP, like what is NLP? It's basically a field of study that studies the interactions between computers and humans using natural language. And it's an intersection on multiple fields, like it's linguistics and how language works, semantic difference, syntactic difference, and basically computer science, how can we model that? And it's pretty popular right now. It's popular right now because there have been some significant advances. Like in the last 10, 20 years, we have gotten pretty good at NLP for some topics. And some of the things that you can do with NLP is text generation. Some of you have seen ChatGPT, that is basically text generation with some prompts and question answering and a lot of stuff, but there is some text generation in the ground allowing that to happen. Name and entity recognition. If I want to find, I don't know, a name of the senator inside of a bill or the name of a building, like we could do that. Question answering models, basically, which we pass some text and we pass a question and the model try to detect and returns what are the parts of the text that answer that question. So when does this bill when was this bill created? Like we can, in theory, train a model to return that date. Summarization, trying to resume a bill or a document into the main parts, and translation too. So now, if you have any questions, please let me know. Or if I'm going too fast, I'm going too slow, like we can go at our own rhythm. So the thing that we're going to do today at the demo is build topic detection. Basically, let me reduce the size. Okay, give me a second. Basically, what we want to find out is, yeah, thanks, Jacob. What we want to find out is, for some users and for persons in particular, for companies, they need to know which bills they care about or not. So maybe a good way to do it is just, does this bill relates to a topic that I care about? If I care about voting rights, I want to know about voting rights. If I care about telecommunication, oil and gas exploration, I want to easily detect bills that treat those topics. So that could be something that could really improve the speed, and it's a good way to start an analysis. So let's try to see if we can get some build data and based on that information, like identify what is the build topic without having to read the complete build. So it's so automatically detect those topics. So we need to install some libraries first. Like you can basically run it and it will install it for you. Once that library is installed, we're going to import what we need. There is a lot of things in there, but not be scared. Like we're going to talk about each one of those later. The first thing that we're going to do then is read the data. Like we downloaded some data programmatically, and now we're going to read some build data. And let's see what information is in there. Okay, so and we're doing some cleaning and some parsing, but the main part in here is reading the data. So let's see what we got. We got a bill identifier, like what is the name of the bill. We are working for Minnesota data. We got some bill title. We got some bill classification. This is relevant. We only want to work for bills for now. And we have some subjects. Like this is an important point because Minnesota give us the subjects, but we're going to see somewhat later that one, they're not perfect, and two, not every state give us subjects. So while this is available for Minnesota, we may not have it for, I don't know, Florida, New York, California. We have some session identifiers, some jurisdiction, and some organization classification. That is the data that we have. So if we want to find that those subjects for other states, that doesn't give us this column per se, that what is a thing that we could do maybe? With the data that we have, I'll say that I will go for the title. Like in the title, most of those times, it's going to make sense to have some information. It's not going to have the full information because we will need the whole bill, but we will have the obvious topic. So maybe healthcare, we have insurance, we have energy policy. So let's go for that for now, and maybe we can see a little bit later. We're going to select only bill data. So basically, what we're doing here is some basic Python transformation and data wrangling using pandas. We can also speak about that later if you have any doubts, but we are only selecting in here the information regarding bills. And then we're going to drop duplicates if there is any duplicates, and we're going to select only bill names. Bill names is the only thing that we're going to use for now. And here are a few examples of bill names. So let's see if it makes sense. So it says some mental health pilots, term and universal life insurance, public policy building solar services, protection and supplement. There is some information there that could in theory guide us to some of the topics. Not all of them, but some of the more relevant ones. So what do we do next? Here, let us know any questions, but basically one of the most common ways to work with text when we're working with modeling is to turn this text into a vector or some numbers. Like most of the models that we work about, they don't receive text per se. Like I cannot input words or a paragraph. So I need to have a way to get that representation of that text in numbers, but that representation in numbers should still sorry, I have a question in there. Okay. This first code that we have in here, it gets the information from bill data based on the data that we got. So it should be pretty similar if it's a CSV. Like if we want to instead get one of those documents, like I want to get bill actions, I want to get bill related bills, bill organizations, like I can do it in a CSV with a very similar code. I might change a few parameters, but read CSV with pandas is going to be a very common way to do it. If we want to get some different non-CSV, a bit more unstructured tests from our sources, it may change a little bit. But for the bulk data that we downloaded, most of it could be read this way. Okay, so if you have any more questions, let me know. But basically, we need to have we need to find a way for us to get those text data into a numerical representation that still makes sense, that still keeps some of that semantic meaning of the words and of the text. So there is a lot of ways to do it. One of the simpler ways to do it is here presented basically like creating a one home vector when each word is represented by a 1 in one position and 0 in another position. That is one of the simplest ways to do it. But if you do it this way, then you can access different models and different way to model the data and to find new results. So that is the simplest way to do it. We are going to use another way to do it a little bit more advanced, but already available to us. So there is a lot of language model, GPT like, BERT like, you have heard some of that about, but basically the main idea around it is they are big models that they're trying to predict what is the next, that they are trying to predict what is the next word in a document or what is the words around the document. That task, we don't care that much about the task, but if we do that with a lot of data, with a very big model, what we get at the end is pretty good representations of text. So we get some vectors for words and we get some vectors for sentences that are semantically significant in a vector space. I know that can be a bit complicated, but basically there is some relation between those vectors that models can learn and use. So we don't care a lot about those language model here, but what we care about is this already pre-trained and given to us open source language model can help us create good vector representations of data. That is what we care about. So basically what we're going to do here is we're going to get a model that is pretty common. It's a small common model in the industry, and we're going to use it to create those vectors. We pass the names and the model takes care of everything. Like there is some tokenization, there is some dictionaries created, but we don't need to care about that. We only need to pass the text and he's going to handle everything. So it should take around a minute, 2 minutes to run if you have the GPU activated. If you see that it's taking 5 minutes, something like that, like let us know, because it's very likely that you're running it on CPU. It's going to download the model. We can test some models later. That is one avenue of possible improvement. But this is a small model, but it's also good for what we need. And another important part is you at the end only want. We could create a representation vector for a word, but at the end, what we're going to use is only a single representation for the whole sentence. So the sentence that we pass, the name, is going to be represented by a single vector, like a list of numbers. That is going to be our sentence now. While it runs, I can talk a little bit more about like the models that we're using. And one of the valuable parts is of those more advanced models is when we analyze a word and when we create the embedding for the word, we care about the words around it. So that is very important. Okay, so we now have the results here. Here's just a show of the first 5 vectors. So you see it's similar. It's not 1, 0, 0, but at the end for each sentence, we have a list of numbers that represent that sentence. So if you don't get this or if it's taking too long, let us know. But why is this model better and why we are not doing some simpler, I don't know, count value, one-shot verification, vectorization, because words have a meaning in their context. Like here it's easy because it's countries, but if I have a clutch or I have a box, what does it mean? What I'm talking about. So the good part about these more advanced pre-trained models is the words, the vectors for the words and the sentences have a meaning and have those vectors created when they are related to each other. So in this case, the word it, that what does it mean it? In this case, it depends mainly on the animal. So it knows that when the word it is present, like it's related and it's meaning to the animal. So that and to and street, there is some words that are related and are shaping what the word it means. So what that is why one of the reasons these models are better. So we have an issue though, like these are 500 and something, 200 and something, 1000 vectors. This is too big. Like if we want to create some visualization or understand better, like what are we talking about? Are those names similar to each other? We can't visualize it in a 500 space. So there are a few algorithms that can help us reduce dimensionality. There is PCA, there is TSNA, but basically without getting too much into the details, what we're trying to do here is we have a vector, we have a list of 500 values that represent a sentence. We want to create a list of 2 values that also represent a sentence. So we can plot it and we can analyze it in a 2-dimensional space. So we can visualize it basically. So that is the main use, so we can understand better the data. It's not going to be a perfect representation passing from 500 space to two values space. Like we are going to lose obviously some information, but the idea is to get a good enough view of the data so we can see some of the patterns. If you have any questions later about what does this library do, how does this work, why we do this, just let us know. So basically, we now moved from those 500 huge vectors to each sentence being represented by those 2 numbers. Like, what does these 2 numbers means? Don't ask me. they are basically representation in a different space that don't have a meaning per se, but they have a meaning when they are related with other points in that space. So if 2 points are close, let's say using cosine similarity or some kind of metric, then this is very likely that those points have a similar meaning. So those 2 sentences are similar in some way. And now that we have this, we can do 2 things. One thing is we want to find if there is some possible cluster. So at the end, we want to see topics, and the goal of us is, okay, maybe I can find 5 main topics or 10 main topics or 20 main topics using this, and then I can test to see if one of the topics is healthcare, the other topic is telecommunication. That is what I care about in the end. But in a lot of cases, we don't have labeled data. So there is going to be an state where we have only the name, but we don't have what are the subjects. So we can train like a model to predict those. So let's see if clustering, like trying to find groups of similar sentences, give us an idea of the topics. Maybe there is a group of sentences that is mainly about healthcare. There is a separated group that is around transportation bills. That is what we want to find about. We did some exploration, we selected 5, but we could put 10, 20, like that is something that we're going to see later why that choice is unimportant, but we're going to put here as an evaluation. We are using k-means for that cluster. That is a clustering algorithm. For those of you not necessarily familiar, it's a non-supervised model. So we don't need to have the label of this is the topic that we want to find out, but we only need to pass the data and it should be able to follow some relationships. And then because we have in 2D, like we can create a plot of basically the sentences. This is not, sorry. Okay. First of all, this is not very great to read. Like there should be a better way to do it. Each point in there represents a bill. So the first thing that we see, we are going to visualize it better. Like there are better ways to visualizing it, and visualizing it is some of the best way to understand data. So let's do a better job about that. So yeah, I can now, this is the same view, but now it's interactive. So I can see each point in here is a bill. So when I put in here any point, whatever, I get the bill name. What was the group that it predicted? So what we see here is, okay, we will go to whatever point. We're going to see, okay, this is the bill titled sodomy, fornication, and adultery crimes repealed. This is this bill, and this bill is close to right of citizens to secure from unreasonable searches, electronic communications, or a right to keep, process, transport, and carry, transfer arms. So it's some right bills data about it. So the first thing that we see here, for those of you a bit familiar, is there is no a clear separated clusters. Like it's just a huge blob. So I guess the first question is the first question that we have is clustering maybe a good way to find groups of bills by topics, since we don't have that data? Maybe not, because if we have some separated group, some better separated groups, we could say, okay, this group one that we find by clustering these points is going to be healthcare group, and this point two is going to be transportation bills. But we have those in a few cases. So for example, if we go to this specific group that you have in here, and let's get, this is a bit separate from the other. So it could be something specific, like I'm going to see, and they are mostly omnibus bills. So there is some information, and the model learns something. So he knows that these bills that have omnibus on it, they are similar. So it's getting some information about the text. Let's see some other groups. If we go up here, for example. These are, remember, like the closest there are in this space, the most similar the two bills should be. So tax authority modified, tax authority modified, tax authority modified. So there are some small groups that they do work and we could classify, but when we go to most of the bills, they are not clearly separated from each other. So at the end, let's go a bit, I'm going to spend some time in here. So if you have questions, if you want to see a specific bill, we can do it. But I want to spend some time because that is kind of the result, and then we see some of the strengths and the weakness that our analysis had. So I think if we go to whatever point in this, so we go, for example, here, we see that the bills that are close to each other have similar names, or have names that point to similar topics. So interchanging highways, expansion of our lanes, this is information about transit. So one of the things that we could say is, okay, maybe our vectorization model, the model that create a representation of our sentences, is working relatively well. Like it's not perfect, but when I try to see if two bills have similar names, they should have a similar vectors, or vectors that are close to each other, and they have it. Not in all cases, but in most cases. The problem that we could go to another spaces in here. We could go text authority modified. yeah, money appropriation, for example, in this case. So that is an interesting thing. Where's the weakness, or where maybe this might not be the better approach for policy topic detection? There is not separate clusters, so there are bills that may not be into an exact group. So how is different transportation, for example, this bill specifically? I lost it. Yeah, special education formula, cooperative unit, special code levy authorization, some tuition bill limiting, appropriations. There are some more than one topic that this bill may care about. So is this bill about appropriation? Is this bill about education? What is the exact group? When I do clusterization, I only add one bill to a certain group. So I am not saying here this bill belongs to the group of healthcare and the group of appropriation. I'm going giving one. So that is one methodological weakness in our approach that we think may not be the best way. We can review things manually. That is pretty useful sometimes when you're trying to analyze what is going on. So here we're going to do, let's wait a second. Here what we're going to do is find for each sentence, what are the 5 most similar sentences or closest sentences? And let's see what are those topics about, if there is some weird things that we find out. So armed forces discharge certificates, for example, is one sentence, and a similar sentence to that based on our model will be firearm transfer criminal background check. So both have some arms, both have some, let's say, military or at least arm background to it, but they are not necessarily from the same topics. There are some topics that are kind of funny. So if we see 7314, we see that there is a government operations local topic and there is a government local topic. What is the difference between them? But the main thing that I think we should see in this data that maybe some people saw before is that in most cases, there is more than one subject. Like this bill is appropriation, but it's also human services. This is human services too, but this is appropriation and this is mental health. There are some few of them with one topic, but most bills, as it should be, is not necessarily a single topic. So clusterization, when I'm adding just this bill can only be this topic, may not be a better way. So there are other ways to model it, like multi-class classification. So we pass a bill and we classify it, and that bill can be appropriation, but can also be healthcare, can also be education. That may be a better way. So a bill can belong to different subjects. So if we go a little bit more around that, we find out that, and this is just a simple analysis that I think we have done it in the beginning, like maybe we have found out, okay, maybe clusterization is not the best way to do it. So that is why it's good to first analyze the data and try to find out a little bit about it and then go to the modeling part. This is also a cautionary story of what to do and what not to do. So what we found out is, in average, bills have 2 topics for Minnesota for the session that we have. They might have up until 7 topics. They might have 0 topics. Maybe that's an error. Maybe that's something that people in there didn't know what to put and they put it something. But even at the 25% hill, they have 2 topics. So it's weird to have just one topic. And the next thing we found out is there are topics that are way more common than others. So bonds is a topic that has 1,000 bills have the bonds topic, 989 bills have the appropriation topic, but only 1 bill has the census and democracy topic. So what do we do in that case? There is at the bottom here, we see that there is 246 topics. So that is a lot of topics in one part that if we give it to our user, maybe is our user going to search and find out which one of those 246 topics do they really care about? Maybe, probably they'll get bored. So if there is like some hierarchical level of topics of healthcare, then I care about child healthcare, veterans healthcare, like that could be a way to approach that problem that will be better for our users. And we also have the class imbalance. Like, could I predict accurately wetlands bills with only one example? That could be a hard problem. So those are some of the issues that we might have to face and to fix if we want to continue with that classification problem. So some of the conclusions that we can get in here is most bills are about more than one topic, like 2 or more. A clustering algorithm may not be the better way to identify those bills. And we will likely require a labeled data set that have some bills and have the corresponding topics. Then we can do some processing, and then we can train a classified model. So a multi-class classification problem may be a better way to tackle this one, because a single class classification problem is not going to work. We have multiple, and there can be more than one class or more than one topic for each one of the bills. Possible next steps. This tutorial was to give you an idea of what you can do with the data, but there is 1,000 things that we could do. If you wanted to continue working on this, that is obviously your choice. You could try to train a classification model with those bill information that we have. So there is some cleaning and some work to do, but that is something that we could do since we already have the data. And an interesting question is, does a model that I train with Minnesota data works with, I don't know, New York data or Florida data, where I may not have bill topics? So if I have bill topics from Minnesota, then can I train a model to classify bills and then use it in states that don't give me the subject, that they don't share the subject of the bill? That could be very valuable. Not for Minnesota. For Minnesota, we have this, but if there is a state where we don't have that information, a model for that could be really useful. Maybe the clustering algorithm was bad and we don't get the right clusters. Maybe the dimensionality algorithm didn't converge because we don't have the best models. Like we use a small and general model, but maybe we could use bigger models to retrain models that Roberta, XLM. We could use specialized models that were trained on legal data, like legal BERT. They were trained on contracts, Supreme Court cases, so they may have some information, or whatever you want to try. You want to use some different data. If you want to take another document, identify some things, we are here to support you. So this was just to give you a brief heads up and some information on what we can do, but please just let us know if you want to do something different and if there is something of value that you want to explore. We will be here all day, so we'll be here to help you with whatever you need. So I think that's it on our part, and thank you very much. If you have any questions, you can let us know. Okay, so basically the next steps here are the rest of the day is a hackathon day. We are going to be here for the person that want to be on premise, but if you have any hackathon ideas where you want to analyze the data, you want to extract some information, you want to chat about data analysis and data science, you can let us know. We will be here and we will help you the best way we can to get some OpenStage data and to get you started on your analysis. And that's it. I'm going to be a bit quiet for now, but we are here on premise and in chat for whatever you want to do. Just let us know. We can go one-on-one if you want some specific, and we can create some breakout rooms if we want to talk about a specific topic on your own. Thank you.